Okay, this lesson is for Science 9s, and what we're going to look at here is we have a chemical reaction. This is our first example, and we need to make sure we know what our reactants are and what our products are. So for this chemical reaction, reactants, remember, are always on the left-hand side of the arrow, and then the products are on the right-hand side. So make sure you have your periodic table so you can remember what these symbols stand for. So Mg, that is magnesium. So our first reactant is magnesium, which is the Mg, and our second reactant is oxygen. All right, so magnesium, which is Mg, and oxygen is O2. Remember, it is diatomic, so it's always found as two atoms of oxygen joined together. Okay, and then our products. For our product, we only have one product here, MgO. So make sure that it's named correctly. Magnesium is a metal and oxygen is a non-metal. So you would name this according to the ionic compounds. So this would just be called magnesium oxide. All right, let's take a look at another example. The next example is we have 2P plus 3Cl2, and it's producing 2PCl3. All right, so let's take a look at our reactants first. So again, reactants are on the left-hand side of the arrow. Okay, so we have phosphorus, that's what P is, and chlorine. So our reactants are phosphorus, that's the P, and our second reactant is chlorine. And again, you'll see it as Cl2 because it is one of the elements that is diatomic. So Cl2, it's always found as two atoms of chlorine joined together. And our product, it's one product again, PCl3. So again, you need to know the name of this, but you have to decide, is it ionic or molecular? So phosphorus and chlorine are both found on the left-hand side of the staircase. I'm just going to quickly show the periodic table here. Here's phosphorus and here's chlorine. They are both nonmetals. So because they're both nonmetals, we have to use molecular compound naming method where we use those prefixes. All right, because there's one phosphorus, we would call that just phosphorus. And then we have 3 chlorine atoms. So 3, the prefix for 3 is tri. So tri, and we have to change the ending to "ide," so it does become trichloride. All right, so that is our product, phosphorus trichloride. Okay, let's take a look at the next example. The next example looks like this. We have 2HgO, and the product's 2Hg plus O2. Okay, so again, reactants are still going to be on the left-hand side of our equation. In this case, we only have one reactant. Our reactant here is HgO. So again, use your periodic table so you know if it's ionic or molecular. Hg is actually mercury. So here is mercury, and oxygen is here. So we have a metal and a non-metal, so we have to name it as an ionic compound. So HgO, it's called mercury oxide. And our products, this time we have two products. Again, on the right-hand side of the arrow are the products. We have mercury, which is the Hg, and then we have oxygen. And again, oxygen is diatomic. That's why you'll always see it as O2. Just going to pause it here. Okay, so looking at our reactants, so reminder, reactants are on the left-hand side of the arrow. So chlorine and sodium bromide are reacting together to produce sodium chloride and bromine. So our reactants are chlorine. It's not part of a compound. It's chlorine by itself. So that's why we just call it chlorine. All right. If it was part of a compound, which we see here, then we would change that ending to chloride. All right. Our second reactant here is sodium bromide. And again, they are ionic compounds. That's why we're using the method of naming them as ionic compounds, because it's a metal and a non-metal. So those are our reactants. Our products are on the right-hand side of the arrow. So sodium chloride and bromine. So again, bromine here, it's not part of a compound, so we would just call it bromine. All right, so those are the reactants and products. We have one more example of this. We have Zn plus 2HCl producing ZnCl2 plus H2. Okay, I'll give you guys a minute to try that. I'm just gonna pause the recording. All right, so we have our next example here. It was zinc plus hydrogen chloride is producing zinc chloride plus hydrogen. So our reactants are the two on the left-hand side of the arrow. So our reactants are zinc and hydrogen chloride. And on the right-hand side are the products. Our products are zinc chloride and hydrogen. Just want to point out here, hydrogen. Just want to point out here again, hydrogen is also diatomic. That's why we see it as H2. When it's by itself, it's diatomic. All right. The next example I'm going to go over is you might come across a word equation. So the word equation here is silver and bromine produce silver bromide. All right, and you might have to come up with the chemical equation. So silver, you would find it on your periodic table. So I'm just gonna, 1 second here. Silver right here, Ag, and it is reacting with bromine. Bromine is here. All right, so when we write this, we would actually write it as Ag plus bromine. Remember, bromine is diatomic, so we would have to put Br2, and it forms silver bromide. All right, so notice silver has a charge of 1 plus, bromine has bromine has a charge of 1 minus, so it would just be AgBr. Correct. So next we're just looking at reaction rates and how a reaction rate can be made to go faster. So one way was temperature. You can increase temperature, so therefore particles are going to start moving faster, so therefore the reaction will occur faster. Another method was stirring. If you have like a solution and you start stirring it, again, you're going to cause particles to start moving faster. Therefore, the reaction will go faster as well. Another method was size of pieces. So if you have smaller pieces in the reaction will go faster versus if you're using one large piece in the reaction. Okay, so think about even like dissolving. If you're trying to dissolve a large piece of candy in your mouth versus when you crunch it up into smaller pieces, it dissolves faster. And lastly was concentration. Concentration of substances. If you have more of that substance, there's more there available to react. So therefore, the reaction can go faster. Another method is the use of catalysts. So reminder, when we talked about catalysts, they speed up reactions without actually changing anything in the reaction. So the catalysts are just there to speed up a reaction. They don't change the product in the reaction. And the opposite to that were inhibitors. Inhibitors are substances that slow down a reaction.